Okay, last couple problems. If you can do a function, if you can write an equation for a function given a picture, given the graph, then you can definitely do it given the description. These are much easier, kind of wind us down for the end of our review. Our parent function is log. I see down 2 units, left 5 units, reflected over the x-axis, and vertically stretched by 5 halves. So I like to kind of do these as a fill in the blank. Feed myself room. So I know I want log of x, that's our parent function. I'm going to go ahead and cross these off as I use them. Vertically stretched by 5 halves, that means that since it's vertical, it needs to be on the outside of my function. And if I'm doing a vertical stretch or shrink, I go with the number I'm given. So 5 halves goes out front. Reflect over the x-axis means I need a negative out front with that 5 halves. Left 5 units means I want plus 5 on the inside. And down 2 units means I want minus 2 on the outside of the function. So if you're asked to do this on the test, I would just make myself a fill in the blank. Just pause. All right, next problem. Parent function is 1 over x. So the thing about 1 over x, outside the function really is on top in the numerator. Inside the function, you can think of that as kind of on the bottom in the denominator there. So 1 over x. Reflect over the y-axis, horizontally compressed by 1/4 and up 3. Well, the easy one here is up 3, so let's get that dealt with. Up 3 is going to be a plus 3 on the outside of our function. So we want that kind of off to the side, not in our fraction at all. Reflected over the y-axis, we need that negative inside our function. And for 1 over x, inside is on the bottom of in our denominator. Now, for 1 over x, a reflect over x is going to look just like a reflect over y. So that placement isn't quite as important, but I like to do that note. Last, horizontally compressed by 1/4. Again, since we're doing horizontal, we want this inside our function. So that's going to be under in the denominator. And then if we're doing a horizontal compression, anytime we're doing horizontal, we flip that number. So if it's a 1/4, what I'm putting in my equation is a 4. And that gets all our transformations with that one. Last, e to the x. You definitely should expect to see e to the x and ln of x kind of all over the place now and forever. They're very important. You'll use natural log a lot. You'll use your exponent rules and natural log and e to the x a lot in this course and in calculus. So I try to kind of have them pop up as much as possible. Our parent function is e to the x. And the thing, so with e to the x, inside our function is going to be up in that exponent, and outside our function is kind of going to be around that e. So vertically compressed by 3/5. So if we're doing vertical, that's going to go out front. So that 3/5 can go out front. Right 2 units. That's going to be minus 2 up in our exponent. And down 7. It's going to be a minus 7 outside. So I left kind of a big gap there. Let me rewrite this guy. Here we go. Great. There's your equation. So the x minus 2 is up in the exponent. The minus 7 is the side function. The side e to the x.